Hello, everyone. George Christie here with Wine Industry Network. Welcome to another episode of the Win Educational Webinar Series. We've got a really good one for you today. It's geared primarily towards our winemaking audience. Pretty technical. It's titled Yeast Nutrition in Winemaking, Your Most Common Questions Answered. Again, very technical. I think you're going to enjoy this one. Today's session is sponsored by Fermentus. Thank you for your support. And the panel is going to consist of Sean Tomlin, who's going to be joined by Ann Flesch. They're both with Fermentus. And to round out today's discussion, they're going to be joined by James Robley, who is with the ATP group. Now, a little bit of housekeeping. As is always the case, we pre-record these a couple of days in advance, primarily for quality purposes. But the good news is Ann, Sean, and James are going to be watching this broadcast right along with you, monitoring the chat room. So as you have questions, go ahead and pop those questions in. You don't need to wait till the end. And one of the panelists will take those questions as they appear. So please take advantage of that. I think that about covers it. Once again, I want to thank Fermentus for all their support. I want to thank you for joining us today. And of course, I want to thank the panel for their time as well. All right, I'm going to hand it off to Sean and let him take it from here.
Thank you very much for your introduction, and we are happy to be here. We are your panelists for today. My name is Sean Tomlin. I am the sales manager for USA West for Fermentus. I have with me my colleague Ann Flesch, who is our technical sales support manager for the Americas. And we also have James Robley, who is the enological technical sales support manager for representative for ATP Group. And thank you both for being here. Ann, James, how are you?
Happy to be here.
Yeah, doing great.
Excellent. So we're going to talk about nutrition in fermentation. But before we begin, we can talk a little bit about where we come from. So LeSaff is our parent company of Fermentus. Fermentus is a business unit of LeSaff, and it's one of many. LeSaff deals with many things like agriculture, cosmetics, food additives. It's huge in the baking industry. It has many different business units in fermentation. It's a global, key international player in fermentation. And Fermentus is like I said, the fermentative beverage unit for LeSaff. So we deal with everything from wine, beer, spirits, kombucha, coffee, you name it. And in wine, specifically, we have a key partner here in the Americas, that's the ATP Group. And James is a part of the ATP Group. They distribute our products, but not just our products, many different enological products, such as chemicals and equipment as well. So that's a little bit about us. Let's dive into our topic of today, which is nutrition. And why do we even care about yeast nutrition? What does it matter? So, of course, we want to avoid problematic fermentations. That's really key. I think if you've been a winemaker, you've experienced at least one, if not many, problematic fermentations, and it often comes down to nutrition. But beyond just problematic fermentations, we're also trying to avoid off characters. Yeast is the flavor engine responsible for 80% of the aroma additive compounds in wine. And we're also trying to promote and emphasize positive aromas. So in the optimal conditions, the yeast will develop their full potential. So how does nutrition drive flavors and also help solve our problematic fermentations? One common fermentation problems that occur there's many different types of fermentation problems, and they all have different causes. Nutrient limitation is the first cause of fermentation arrest, and nitrogen is often the most common cause. But beware that the combination is a combination of factors. It's not compounding necessarily, but can also be synergistic with each other and cause and relative to each other. So what we're going to show throughout this talk is that the optimum conditions for fermentative capacity or the viability of the cell. The vitality of the cell, the health of the cell, plus optimum conditions for yeast growth, meaning the viability of the cells. This equals optimum fermentation. We're going to wrap this nicely into a nice little bow for you, going through each factor and how nutrition can be a lever for the success of your fermentation. So let's dive into it. Let's start actually from a very basic question. What does the yeast need to grow and ferment? So let's begin there. Let's bring in our two main panelists here. Anne, you are the wizard here. Please start us off and tell us what we need to know.
Yes, thank you so much, Sean, for the introduction and trying to put everything in context. Obviously, nutrition, it's been a topic for a long time, and it remains a priority for healthy and good fermentation during harvest. So what we're going to try to do is really take you from, the beginning, but also try to build up pretty quickly to take you to, the latest research and things that we've learned, in the past decade about yeast nutrition being really present with you winemakers and understanding your needs. So like you said, Sean, I'm going to start with talking about what the yeast needs, kind of the basics. There are two categories of nutrients that the yeast is going to need: the macronutrients that you can consider the building blocks of the cells, the yeast cells, and then you have the micronutrients that are just necessary for the reaction within the cells. So I'm going to focus on the macronutrients. Obviously, the yeast to grow and ferment needs a source of energy that's going to be carbon based. So it's going to be very easily the glucose and fructose, and in your must, it could be other sources of sugars for other fermentations, in beers and things like this in wort. The second one, in order of importance, is nitrogen. Nitrogen is key as a building blocks of the cells, for the protein synthesis to the synthesis of genetic material or, molecule carrying energy in the cells. It's really everywhere. Transporters, it's necessary at every stage of the fermentation. And that's why people focus so much on nitrogen. You also have phosphate or sulfur that tends to, not be pragmatic unless you have too much of it, and it can happen with sulfur, and we'll talk about it at the end. And something I want to focus on is what is generally called survival factor, that can also be said as, category of the lipids. And overall, obviously, to create new cells, the yeast needs lipids especially to generate new membrane, strong membrane that will resist the conditions. And that can be provided under the form of, different lipids, fatty acids, sterols, phospholipids directly to the yeast cells. But it can also we can also help the yeast produce these molecules by providing oxygen at key moment of the fermentations. So these are generally the macronutrients, and I'm going to let James focus a little bit on the little guys.
Thank you, Anne. Yeah, the micronutrients are often overlooked as an essential factor in your nutrient regimen. They're essential for growth and proliferation of cells in wine fermentation, often playing the role of enzyme functioning control and stress management. So that has an effect on the yeast metabolism, fermentation kinetics, and of course the organoleptic profile of the wine. Generally, micronutrients is split into two separate categories of vitamins and minerals. Vitamins that highlight include biotin, which is involved in the synthesis of esters and amino acids, as well as the metabolism of fatty acids, as well as thiamine, it's a yeast growth factor essential for converting sugars to alcohol. It improves the alcoholic fermentation start and is essential for avoiding a sluggish or stuck fermentation. Minerals are all elemental compounds that may be found in the wine juice or in your nutrient supplementation. Things like manganese and zinc, which are essential cofactors for enzymes breaking down glucose and fructose, as well as protein synthesis and alcohol production, as well as potassium, which is crucial for maintaining cell turgor and cell health.
All right, so I understand we need to coordinate all of this, the macronutrients, micronutrients, as nitrogen, lipids, vitamins to have a good program. All right, so we talk a lot about nitrogen. It's been a topic for many, many years, but in the past few years, a lot of research has been focused on the importance of lipids, and I just wanted to just make a short focus here, showing a trial from the literature here. And here you can see it's in a synthetic must, and you have a good concentration of sugar and a great, actually, concentration of available nitrogen to the yeast. So technically, very good conditions for fermentations. But you can see that in this trial, we had a control, and then they added different dosage of sterols. And you can see we follow the release of the CO2 in the fermentation to follow the fermentation. And you can see that the more sterols were added, first of all, the faster the fermentation, the sooner it ended. So there is definitely a benefit to not just adding nitrogen, but to added lipids, because it will increase the fermentation rate and overall reduce your fermentation duration in a steady way. And so also, if you are deficient in lipids in your fermentation and you only focus on nitrogen, you're going to have yeast that can build a healthy population, but then can be a little bit weak in the membrane, and that cannot handle the end of the fermentation, the toxicity of the ethanol, of the fatty acids at the end. So just we want to put a little bit of focus on the lipids here in this presentation. And actually, in the past few very, very recent years, there is now a huge focus on vitamins as well. And I think there would be some exciting new publication in the near future about that. And so these were kind of what the yeast needed. To answer the question.
Interesting. So we're going to ask this question here. Is there an optimal amount of nutrient to add? So is there a right and wrong amount? Can we just add whatever we want? Can we cross our fingers? What are we looking at when we're adding, and how do we tell how much to add to our fermentation?
Yes, it's a very good question, and actually the answer is very complex. So, is there an optimal amount? The answer, there are many aspects of this question. Yes, there could be an optimal amount, but you have to know what is your objectives. Is your objective to optimize fermentation kinetics? You want it just to be complete. You want it to be complete and super fast. You want it slow and steady, and the amount of nutrient you're gonna add is gonna play on that. Is your objective to mainly focus on a very consistent wine analysis, VA beyond a certain level? SO2, we know that there are optimal amount of nutrients for the yeast to be as less stressed as possible. Do you want to focus on as low as possible off flavors for specific lots? We also know you may need to add more specific type of nutrients to prevent sulfur of flavors and things like that. Aromatic profiles, esters, varietal aromas, same thing. We may have a different optimal amount of nutrients for you as a recommendation if your emphasis is going to be on optimizing aromas in your wine. So yes, there is an optimal amount, but you need to define your objectives first. The second, and we'll talk about all of this, through this webinar. The second part is yes, but also you need to know what the microorganism you are using, mainly the yeast, but also the bacteria, how much nutrients they need. There is a huge variability, and we'll focus on this in the next slides. The third one is, okay, obviously we talk about fermentation here, so we need to focus on, the yeast and its need, but you need to look at your overall process. There are things that you do, before fermentation, your fruit, the harvest, the way the choices you make in winemaking process that will affect overall how much nutrient you need to add. And we'll try to talk also a little bit of this with James. Okay, so let's start with the yeast. We say yeast have different needs. So this trial is trying to highlight this. It's a trial on Sauvignon Blanc that we did, where you can see the amount of yan is pretty low compared to the amount of sugar. Actually, the ratio yan to sugar is 0.45 with a medium turbidity. And we tried 16 different yeasts at 68 Fahrenheit. And what we tried to do is the behaviors they had without adding any nutrients. Can we classify the yeast by big groups? And we measured the release of the CO2, the cumulative CO2 to follow fermentation. So at 105, we consider it to be a complete fermentation here. And we can see the strains, each line is a strain, different strain, have very different behaviors. We have some that, we have a big group that completes fermentation, some of them being very fast, some of them being fast. And here's where we define this group here. Then we have some that are sluggish at the end here, but do complete fermentation. And we have another group that's stuck, that cannot complete fermentation in this condition. So clearly there is a need, to take into consideration the yeast in this particular composition of must. And so overall, there is a need to have a balanced nutritional program, bring a resource to meet each yeast needs in a specific must.
Oh, that's great. I want to bring Anne in first. I want to bring James in for a second here and just ask if you've experienced yourself personally or with your customers different nutrient programs based on the yeast needs. Is this something that you get questions on or have dealt with yourself personally?
Yes, that's a great question, Sean. So generally, a winemaker will have a favored yeast for each of their different wine programs. And this is going to go well beyond this yeast is recommended for red wine, this yeast is recommended for white, to look at, nitrogen requirements, but also aromatic compounds that are expressed or inhibited, yeast's ability to add roundness and weight, and the yeast compatibility with MLF. And those decisions are also going to influence the need for and the type of fermentation aid that the winemaker is going to choose. In the past, we know that nutrition starts in a vineyard, so let's back up and start there for a minute. I've seen grapes come into the winery with yams over 450 ppm and as low as 71. So there's a lot of latitude there to select yeast with varying nitrogen demands, acid tolerance, conversion efficiency, etc. And the selection of the right fermentation aid is critical, especially for those low nutrient musts. And on the topic of the variabilities of yeast nutrition, starting with grapes, what that looks like in the must. Well, so must is the movie set in which all of the action is taking place during fermentation. And of course, each one is different. So the biggest variables are, of course, sugar concentration, which can range from low, partially unripe grapes to high, overripe grapes. And throughout that entire spectrum, the monosaccharide profile is going to change as well. Grape variety must also varies in concentration and composition of assimilable nitrogen, which alpha amino nitrogen usually accounts for around 2/3 of the yan, and free ammonia nitrogen for about 1/3. Lipid composition of the must can also vary due not only to the quality of the grapes in the must, but also how the grapes are processed. Specific example of that is a depletion of lipids and other biological factors in overly clarified musts, and that needs to be corrected within the fermentation aid nutrient regimen. So, and then of course, as we talked about previously, vitamins in the must are entirely dependent on soil composition and health, and they need to be assessed and adjusted for accordingly.
Right. And so in relation to this must now, as a yeast supplier, we, because we have observed, and highlighted in previous slide, different behaviors of yeast, we classify yeast in different categories in terms of the nitrogen needs, because it is their, primary macronutrients of need to ferment. So here we try to simplify things for you. We classify them as, different category: median requirement nitrogen yeast, and that would be kind of, I would say, the averages on the market. I would say this is a good data to use. Here we use the code 2Ns. Then we have low nitrogen requirement yeast, 1N, and high nitrogen yeast. And what you can see is we provide for you, to make it a bit easier, for each yeast, the ratio of how much yeast available nitrogen they need per unit of sugar to ferment. So we have 2 units here for you, whichever is the easiest to use. Either it's yan per gram per liter of sugar to ferment, or, if you are in North America and you prefer to use bricks, we also provide the equivalent in an average yan to bricks ratio. So I'm going to use this one just to guide you. But so to give you an idea, a low nitrogen yeast will need 6.5 to 9 yan per bricks to ferment in average. A medium yeast would need 8.5 to 9, and you can use, any number in this range. And then a high nitrogen need yeast will need 8.5 to 11. So quite a lot of variability between 6.5 and 11. Now, something to say, and we will focus at the end of the fermentation, if your objectives is not just to complete fermentation, it is to have a faster fermentation or optimize aromas, we do encourage you to have higher ratios, and 10.5 to 13.5, are ratios that, you could select of yan per degree bricks if those are your objectives. So let's take the example of a must that is at 22 bricks, and just to see what it looks like for different yeast. Here with 22 bricks, a low nitrogen yeast, we need anything between 144 and 192. Medium would be, like I said, around 192, and then high nitrogen yeast could be as high as 240. And to optimize aromas, we could be as high as, 288, almost 300. So see, it's almost a factor 2 between the lowest and the highest range here of recommendation. So to answer your question, is there an optimal amount? There is, but you need to take into consideration all of this. And so just to, to see how this applies, to the concrete world of, yeast existing on the market, maybe Sean, you can show us how, give us a picture, for example, in the fermentis range of the nitrogen needs, for example.
Yeah, well, on the screen here, we can see a good infographic, one that's common in our catalog, and you can find through our website as well. It's a really good kind of straightforward look at our yeast strain selection based on their kinetics, their kinetic speed, their difficult condition resistance. And if you look at the ends next to the ends there, if there's 1, 2, or 3, gives us an indication from the previous slide as to their nutrient needs. So, and you can see they're very correlative, right? So the faster the kinetics, oftentimes the stronger it is, the more resilient it is for alcoholic fermentation, but also the less nitrogen needs, the less nutrient needs that the yeast strain requires. So down at the very bottom, we see a slow fermentative UCLM S377 or UCLM S325. Both of those are highly requiring, or they're requiring more nutrient source than say the top there, BCS 103. And they're also going to be a little bit more moderately subjective to the stress conditions of alcohol fermentation. So just a good infographic all around, and a lot more information behind that is available on in our catalog and our website as well. But beyond just what we've talked about, which is, our must concentration, our YAN levels, and yeast strain selection, can we talk a little bit about some of the other factors that might be involved as far as things to consider when picking a nutrient and how to use it?
Absolutely. Yes. Obviously our big focus is on yeast, but there are many things that you do in your winemaking process that will eventually affect and should affect your decision on how much nutrient to add. Some of them are in relation to the fruit itself. The grape variety, for example, we know some variety or, can be problematic in fermentation. Some winemakers I always have a problem with my Syrahs. The must composition of specific varieties may be low in specific amino acids and things like this. So just from your experience, white versus red, there is definitely, and then specific variety from specific vineyards. So history of a lot. That you need to keep track of, and that you know the best your grapes. The second one is the sanitary state of your grape. And if your grape comes in with very poor sanitary state, it means that some microorganism can, already grow and utilize all these nitrogen vitamins in the must before you even inoculate or start alcoholic fermentation. That means you're going to start potentially very low. So that's something to consider in, your nutrition program. Specific vintages. Obviously, we know some vintages come in, they always comes with surprises. Some of them can come with very low nitrogen. You have a drought, and then you have very low nitrogen, especially in ammonium. And that's something, you have to react quickly that year and just adapt your nutrition programs. The second part is more like in relation to harvesting. And I would say pre-fermentation as well. Obviously, the time of the year you harvest, the later it is in the year, the more, again, the ammonium in your grape, in your must can decline. So you're going to have less available nitrogen available, and you may also have increasing Brix. So the ratio is not going to be in your favor. The practices of harvest, whether it is manual or machine harvested, might impact sanitary state and potentially contamination and start of fermentation and utilize this nitrogen and vitamins. If you use or not SO2, you're going to have growth of other microorganisms, and again, they can use these resources. Same thing if you use a non-Saccharomyces for bioprotection. Some of them need some of these nutrients in the first place, and you need to kind of replace or make sure that, the yeast coming after has what it needs. Levels of clarification, James talked about it. It can seriously affect the composition of the must, not only in lipids, but also in just support function for your yeast overall. If you do a cold soak for red wine, that could also utilize the non-Saccharomyces there that are tolerant to cold, can also use these resources. Stabilization, same thing. Long pre-fermentation phases. And I'm going to let James talk a little bit more about fermentation itself.
Right. So every aspect of or detail of fermentation is going to have an effect on yeast metabolism and the nutrient regimen that is necessary in order to correct for that. Starting with fermentation temperature and pH, both of which your yeast is going to have an optimal range, and too high or too low is going to stress the yeast, possibly slowing metabolism and affecting the finish of your fermentation. Similarly, inoculation rate affects the fermentation length and vigor, and in some cases, the ability to finish fermentation. fermentation speed, which can be related to fermentation or inoculation rate. If your fermentation is a little bit too slow, you're inviting microbial infection. You may fail to build up enough yeast biomass. And if your fermentation is too fast or too hot, your yeast have the potential to grow too quickly, run out of nutrients before they run out of sugar. And you can also lose flavors or end up with some cooked aromatics in your wine. Oxygenation throughout fermentation is important for a variety of things relating to yeast health and uptake of nutrients, and can affect both the redox potential of the fermentation as you go, as well as aromatics that are built throughout the process. And of course, malolactic fermentation, if it's done concurrently with the alcoholic fermentation, you have competition for amino acids with the yeast, as well as the potential to build up potential toxic compounds such as acetic acid.
All right. Yes, these are all great points. So only you as a winemaker, know all of this about your process, and you need to consider all of this in your decision about how much nutrient to add. So practically, let's just kind of summarize what we just said. How to do it? First of all, well, you have selected your yeast, or you select your yeast. You have to identify its need, how much YAN it needs per, amount of sugar. We classify them in 3 categories: 1N, 2N, 3Ns, low, medium, high nitrogen needs. I know other suppliers, have different ways or similar ways of classifying, but you need to get this information. And again, I remind here, the ratios that we suggested in the previous slide. Once you have that defined, you need to decide, do I want to reach this minimum target, or do I want to actually optimize aromas, maybe speed up fermentation a bit further and go a bit higher than that, So consider what ratio, what number do you want to do? Then you're going to evaluate your YAN need. You're going to multiply your bricks by the ratio you have chosen based on your objectives. And of course, you need to consider what you have in your must. Ideally, it will be through analysis of each individual must. If you have to, you can rely on history or on, group data from different lots. But ideally, you would have each individual must measured for the YAN composition and breakdown. And you would subtract how much you need. You would subtract how much you have in your must compared to what you need to know how much you have to add. Just an example quickly. Imagine you have a must, red must at 25 bricks with an initial YAN at 100 ppm in the must, and you use the yeast Safano HGS 135 that we classify between 1N and 2N. So we're going to take the hypothesis that it's in low nitrogen. So how much you need is 25 bricks multiplied by the ratio 8, and that's 200 ppm. And then how much to add is 200 ppm minus what you have in your must, 120, which is 80. So you have to add 80 ppm to have a healthy fermentation that will be complete and that will not be sluggish at the end. So that was just a practical example.
That's great. So let's move on to our next question here. Are yeast-derived or complex nutrients really more beneficial than mineral sources of nitrogen alone? And maybe before we even answer this question, we can kind of unpack this question a little bit and give some clarification as to some of the terms that are in it. Yeast-derived, complex nutrients, mineral sources. What does this all mean?
Yes, absolutely. I think, there is a lot of confusion out there just because also everyone is using different terms. So just to make sure we start with all understanding, the same things. One of the objectives of this webinar is also to give you the basis of understanding the nature of the product and what you can use for different different objectives. So different categories of fermentation aids out there on the market. The first one, what we call mineral sources of nitrogen. It usually refers to DAP, diammonium phosphate. It can also be ammonium sulfate, but this has been less and less used in the wine industry due to the sulfur component of it. Mineral sources of nitrogen only contain ammonium ion or ammonia as a source of nitrogen. So they don't, unless they are enriched in specific vitamins, they're solely source of mineral nitrogen. Then what we call the yeast-derived nutrients usually refers to a nutrient that is 100% yeast-derived. It means there is nothing else added but different portion of dead yeast. And it contains usually both amino acids under the form, amino nitrogen under the form of amino acids, small peptides that, the yeast can use, and a little bit of ammonium in small proportion that are naturally present in the yeast. And then along with that, you have many other things, vitamins, lipids, minerals. And we will unpack this a little bit in a few slides. So if you look at, this is what a yeast looks like, right? You have intracellular content, you have the membrane, the cell wall, the membrane. Here you have a close-up that constitute what we call the yeast hulls all together. In the process of producing yeast derivative, first of all, it's an expertise. And LeSaf has had a lot of, very long experience at producing these yeast derivatives. You can usually on the market, there are kind of different categories of products that are classified as yeast-derived products. You have what we call the yeast hulls, and that's only the outer layer of the dead yeast. Then you have what we call the inactivated yeast. It's pretty much a yeast that is quickly inactivated. We don't extract a lot from its intracellular content. And then the more we push the process, the more we start extracting what's inside the yeast, and that has really packed in nitrogen, amino nitrogen, and vitamins. And that's what we call autolyzed yeast. Most nutrients out there are autolyzed yeast, but they're not all equals in composition. And then if you extract everything from the yeast hull, you end up with the yeast extract that is 100% soluble. And this is very rich in nitrogen vitamins, but is not authorized for use in winemaking just as a single product. So we're going to find these three categories of products as main nature of yeast-derived product. Now, a complex nutrient is usually a blend of the two. It's usually a blend of mineral sources of nitrogen, so DAP, different yeast-derived fractions. It could be any of those. And usually, sometimes there is exogenous vitamins added to that to make it an all-in-one fermentation that's supposed to be balanced for all the yeast needs. So that's just for a quick recap of the words. We debated a lot between the three of us. We had a lot of trials to display to try to answer this question. 100% yeast autolyzate versus DAP in the same fermentation, a complex nutrient. We had many trials. We decided to select one to really highlight and make our point. This is a trial that was done where we compare a yeast autolyzate of our portfolio, Spring Ferm Extreme, and DAP in a gamay. Where you can see you have a YAN on 115 and sugar to 40, so a ratio that's not really favorable to fermentation. And we tried it for many different strains. Here we're just highlighting three strains that have different nitrogen need. The first one being the most demanding strain of the three. And what we did is we added either no nitrogen, or we added, different sources, a mineral source of nitrogen, DAP, at 90 ppm, or yeast autolyzate, total yeast autolyzate, Spring Ferm Extreme at 36 ppm. So almost 3 times less nitrogen, a real nitrogen addition. And we measured the duration of the fermentation. There are always two data here per color. It's just because we did the trial at different turbidity as well, but we should not focus on this. And what we see is that in both cases, whether we added DAP or Spring Firm Extreme, we see a reduction, a decrease of the time from 15 17 days to 10 days. First of all, the fermentation did finish in all cases, which is, very, very nice, consider that it's a low amount of nitrogen. But we save time considerably with a nutrient. But there are equivalent impact, even though there are very, very different doses of nitrogen. So it kind of shows that nitrogen alone does not explain the fermentation power of yeast-based nutrients, number one, because its content in lipids, mineral, vitamins, support elements provide something else that the mineral source of nitrogen does not. And this is what we we refer it as the fermentative power of a yeast-derived nutrients that cannot just be explained with YAN. And again, we have a lot of trials that highlight this type of condition. We can see 3 times more fermentative power than YAN coming from DAP. Other things that we see, and that's just a quick thing, is very, very commonly people experience using yeast derivatives, yeast-derived product, a complex nutrient, more wine that have overall a better balance, a nice mouthfeel, a stronger aromatic intensity and fruitiness compared to 100% DAP. So this is another quality benefit that people get. And here you can see it's a trial on Macabeo, where we compared 100% DAP versus 100% vinyl liquid, which is a liquid yeast autolysate in our portfolio. So really, that's another benefit that we wanted to highlight.
Great. So a ton of information there already. I think we need to step back and kind of summarize what we've talked about. And, we've broken them down into basically 2 realms: the fermentative compounds that are produced during fermentation and how we control them with nutrition, but also the fermentation performances. Maybe we can have you both discuss one or the other. James, why don't you begin with the relative benefits as they pertain to wine quality?
Right, Sean. So the importance of having a proper nutrition program for your yeast when you're making wine related to wine quality is, of course, to increase favorable aromas, both fermentative and varietal from the grape, as well as to prevent off flavors that could form instead. You can also increase your mouthfeel or roundness and palate weight, and similarly prevent oxidation of aromas or loss of color. And of course, it's going to be important to optimize your yeast choice and investment in the yeast.
Great. And then just in relation to fermentation performance, like we have said, using yeast-derived or complex nutrient can really help. First of all, have a more uniform fermentation speed without, peak of temperature and fermentation, a little bit more tempered, help complete fermentation, help avoid stuck fermentation. But also just, even in fermentation where we have enough nitrogen, we've seen, especially nutrients rich in vitamins and lipids, it can really help shorten fermentation as well. And just especially avoid the last, third of the fermentation to be sluggish. Also, yeast-derived nutrients are a great help for overly clarified musts that are poor, in support in lipids. And finally, to support malolactic fermentation, because, bacteria does also need, different source of nutrients, one of them being nitrogen. And they need organic sources of nitrogen or small peptides to grow and be healthy and be able to ferment. All right, well, that's just to wrap up on this. We can move on to the next.
Yeah, so we've talked about the why and the how much, but we need to consider one of the more hotly debated areas as far as nutrition additions, and that's when do we add it? Is it all up front? Is it in the middle? Or what's our approach that we should take on this?
Absolutely. There is a lot of debate. Each winemaker has its own program and how they like to handle things. I think there are different things to consider just to make sure you build something that, works efficiently. There is such thing as, general good rules for timing addition for optimal fermentation. Here you have just a general fermentation curve. So I'm just going to point out to the main things, the density here in gray. And then you have in pink the yeast populations. And what's important to notice is that you have different phase, right? You have the lag phase where the fermentation doesn't start, but the yeast grow. And then you have the exponential growth phase where you start seeing, the density go down. And then you reach what we call the stationary phase where there is no growth, just maintenance of the population and fermentative behavior until the end of the fermentation. And what we need to know is that the yeast is going to need both nutrient to create biomass, to reach this healthy yeast population. Then you're going to need enough nutrient for this population to have a nice maintenance and finish fermentation efficiently. So we're going to need both. And in your addition, you need to consider this. So just best practices for nutrient addition based on facts. And James and I are going to kind of tag team on that one. We're going to look at the fermentation timeline and give you a recommendation. The first one is before inoculation of your yeast. Early additions before addition of yeast can feed the wrong population, bacteria, native yeast that you may not want them to grow. So.
Right. Therefore, we do not recommend additions of nitrogen-containing nutrient before inoculation.
Yeah, exactly. All right. The next one is we also know that if you have, the higher you have of a population, the more nitrogen demand you're going to have during your stationary phase. So that's going to have an impact as well.
So it's important to not overload all of your nutrients close to inoculation when your yeast are first starting to grow.
Exactly. Second one is we also know that typically in most organic nitrogen is not deficient at the beginning, and also that it can take more energy to the yeast to use mineral nitrogen. So at Fermentis, we tend to recommend something. It doesn't mean that it's the way you have to do it, but that tends to work in mass fermentation.
And that recommendation is to add your mineral nitrogen supply at the beginning of fermentation, and then your organic nitrogen supply 1/3 to 1/2 through fermentation once you've started to deplete some of those other nutrients.
Yeah, exactly. So I say it works in mass fermentation. That being said, with some exception of very deficient fermentation and where you might want to add this organic nitrogen a bit sooner. Another thing is we also know if you add too much nitrogen at once, you're going to have fermentation too fast, rise of temperature, lead to sulfur of flavors, and that can be problematic.
So it's very helpful to split up your nutrient addition if you're adding more than 40 ppm of GAN equivalent.
Right. So you can break down in as many additions as needed if it's only 2 additions, but if you need to break in 3 or 4 additions, we recommend to do that. And finally, at the end of the fermentation, because the ethanol is increasing, it will impact the membrane integrity of the yeast. And at some point, there will be so much ethanol that the yeast won't be able to import nutrients. And that has consequences as well.
Yeah, for that reason, you should not make your nutrient additions after the fermentation is halfway complete. It also allows your yeast to use up the nutrients, and you'll have less residual to feed spoilage organisms during aging.
Yeah, that's a good addition. All right. So practically, just to conclude this chapter about about timing of addition. We left it, as you have evaluated how much you needed to add. The next one is to define the timing of your nutrient addition. If your must has at least 150 ppm of YAN and is not deficient in amino nitrogen, then you do not need to add specifically at inoculation. You have enough to build that population. But you should consider adding at 1/3, half of the fermentation, the nutrient to reach your target. Now, if your must has less than this 150, and that's really a minimum that I'm suggesting, or is deficient in amino nitrogen, you should supplement an inoculation to reach at least this amount and help with yeast growth, and then you add the rest later. So, an example here, we're talking about a medium nitrogen yeast with a YAN to Brix ratio of 9. And here you have different concentration of sugar to start with. At 20 Brix, you're going to need 180 ppm. At 26 Brix, you're going to need 240. You're going to see that, you're going to need at least this amount to start with. And if you don't, you need to complete 250 as up to 180. And then all the rest you can add a bit later between 1/4 and half of the fermentation. We also have plenty of protocols that are much more detailed than that, and we're happy to share that with you. Or if you want to share your objectives, we can create tailored protocol for you. So feel free to reach out as well.
Okay, well, let's move on to our next chapter and question. What are the differences between fermentation aids we can find on the market? And maybe, James, you have a pretty unique perspective in your position to see a nice vantage point as to what the products are that are out there and what the differences are, and maybe some of the questions that are coming from your customers.
Right, Sean. Yeah, so from a market perspective, YAN is king. That's going to be the first thing that a winemaker is going to look at when they're trying to select a nutrient, outside of price, of course. And there's a wide variety of different nutrients on the market. So after that, then a winemaker will look at other factors such as added cofactors, thiamine, biotin, etc., the composition of the nutrient, partial versus complete yeast autolysate, or program suitability for their wine. For instance, if that wine is going to be organic or vegan, etc.
Interesting.
Thank you for sharing that, and I agree with that the perspective. I have the same feedback from the market.
Maybe we can talk a little bit about our products at Fermentus, Anne.
Yeah, absolutely. Yeah. So I want to say a lot of things that I'm going to share here applies to product on the market, and I want you to take that home message. You need to choose the right yeast-derived product for you and for what you want your usage. And to do that, you need to just, first of all, understand them a little bit better, not just take for granted what is said, on the technical data sheet. I did explain previously in this talk a little bit about the different type of yeast derivative: inactivated yeast, partial yeast autolysate. You can have autolysate that are more or less extracted, where we extract more or less of the nitrogen and vitamins. So you can understand that that's going to have an impact on their composition. Once we have this autolysate, where we separate the outer layer and the inner layer, we can separate the two fractions to have just a yeast hull. We can have this as a single, ingredient for you. And this, obviously, a yeast hull is not going to bring the same thing to your fermentation as, a yeast autolysate. So overall, this is kind of, to see the different products, the type of products that you find in the market and what they will bring. You can see yeast hulls. They will be really rich in lipids, in fat matter, but very poor in vitamins and amino nitrogen. On the other side, you have autolysate. They're going to be very well balanced. They're going to have a lot of amino nitrogen and vitamins, but depending on the autolysate as well. Inactivated yeast, you can find some on the market that are, nutrients, but they're not very rich in nitrogen either. They're, they can help, but don't use them as a main source of amino nitrogen, or you're going to have to add really, really high dosage. And so we wanted to share some information about our product, just so to give you some perspective even within the Fermentives portfolio. So we're going to show you some nitrogen composition, lipid composition, and vitamin composition of our product. And this is all normalized to 1, so you don't see, all the detail of the quantity, just to give you some references. We have Spring Ferm Extreme. Spring Ferm Extreme is our total Autolysate. It is the richest in nitrogen in all products by weight, and you can see how diverse it is. Here you have the different amino acids that compose a product. It's very diverse. It brings a little bit of all amino acids that's very well balanced for the yeast. Other Autolysate like Spring Ferm or Vinny Liquid, you can see they're not as rich. They're not as extracted of Autolysate. And they are more or less rich in, Vinny Liquid is still very, very diverse as a product. And Spring Ferm is still very rich in nitrogen overall. Then you have Yeast-Hulls, very poor in nitrogen overall. And Equilibre or Complete is our complex nutrient. And you can see that in gray, it's actually the ammonium. That's the DAP part added. Depending on what you need, you're going to have different type of nitrogen and different quantities as well.
And I think this is really interesting, and you're going to show lipids and vitamins as well here in a second. It's really interesting, the different makeup of these nutrients and how different they are. Can you give an example as to like a case you would use one and a case you would use another?
Sure. I would say for example, in fermentations that are not, overly deficient in nitrogen, Spring Ferm or Vinny Liquid are perfect to provide, the right amount of amino nitrogen. They can be completed with DAP as well. And then, in very challenging fermentation, Spring Ferm Extreme, where it's very low in amino nitrogen, is a great source of amino acids. So this is why it's called extreme, actually, for example.
Excellent.
But, we need to look at the whole picture. So look at now at, the lipid composition. You kind of see that it turns around. You don't have Spring Ferm here. You just have the 4 products. But you can see really the products that are poor in nitrogen can be very rich in other things like lipids. And Spring Cell is very rich in free fatty acids, sterols, phospholipids. Spring Ferm Equilibre as well has, a good portion of hulls in there. Vinny Liquid is our Autolysate that's the richest in lipids. It's well balanced as well. And these products, especially the Yeast-Hulls, can help provide lipid support detoxification of the yeast membrane. And we recommend to use them during the second half of the fermentation to really prevent stuck ferment. And even though they don't provide that much nitrogen, they can have a very strong fermentation power as well. And then looking at, the vitamin composition, that's very interesting to me. Here you can see the Spring Ferm Equilibre, that is our complex nutrient, because there is added thiamine here in green, is the richest in vitamin. It's a little bit less complex though because of the added thiamine. Spring Ferm Extreme, again, this total Autolysate, very rich in vitamins, especially B5 vitamins. That can really help with preventing sulfur off notes in fermentation. And again, that's why it's also called extreme. It really helps in extreme situations. And I wanted to conclude this kind of part about, are all the yeast-derived products in the market equal, with comparing 2 products that on the paper are similar. They're 2 yeast Autolysate, 2 nutrients that are rich and balanced in everything, Spring Ferm and Spring Ferm Extreme, and show how they had different composition. Now, do they have different effects? Here we have a synthetic must, and we have either added nothing in a test in red, or Spring Ferm and Spring Ferm Extreme at the same dosage. And you can see here is the time where we added it. We follow again the release of the CO2. And what's really interesting is at the end of the fermentation, compared to the test, we see Spring Ferm, you have a gain of 7% time of the fermentation time. Spring Ferm Extreme, almost twice as much, 13%. So definitely different products, but also with, different effect, even though they are both yeast autolysates. And you can, apply this to everything on the market. There are, products that are going to have different qualities and different effects on your fermentations as well. And so at the end of the game, the way we talk about how do we communicate about our yeast-derived products, we established, I hope we established by now, that the YAN on the product is not sufficient to express the efficiency of a complex or yeast-derived nutrients. The quality of the added nutrition can sometimes compensate for the real content in yeast-available nitrogen in these products. Therefore, we need to choose another unit to talk about their value. And that's what we call the YAN equivalent. And you can see in our documentation, we talk about YAN equivalent. I know some competitors do as well. Some don't write YAN equivalent, but still talk about YAN equivalent. So you have to be, just very knowledgeable about these things and aware. But overall, one YAN equivalent represent the equivalent effect of one YAN provided by mineral source. And that's what we call the fermentative power of nutrients. And we can look at our portfolio here. Sean, I think you wanted to talk a bit about where we can find this information in our documentation, maybe?
Yeah, so we have a wine catalog that's readily available that shows all of this information really in depth, gives you this YAN equivalent measurement. And this is also on our website. If you just look up fermentis.com, you can go to each one of our strains and you will find a TDS sheet that provides you with this information very clearly. And if you can't find it for some reason, or if you want even more in-depth information, you can certainly reach out to any one of us directly, and we can point you to even further information, different our R&D tests to laboratory evaluations. There's a whole catalog of information behind each one of these strains and their and whitey products as well, functional products. So please look out. Reach out, and the information is there.
Great, thank you. And also, just in relation to the trial that I just showed, you can see that Spring Firm versus Spring Firm Extreme, it has twice the fermentative power, in reflection to different composition and different effect on fermentation. And I think we're just concluding on this with James kind of doing a little bit summary for us on what products to use when.
Thank you, Anne. We have a pretty easy to follow decision tree graphic in order to help you pick out the nutrient that is going to best suit your needs from the Fermentis catalog. So starting with, if you're looking for an all-in-one complex nutrient that already has your DAP contained to it, you're going to go towards the Spring Firm Complete, the all-in-one health package for yeast. Brings a perfect balance of organic and mineral nitrogen, sterols, detoxification power, minerals, and vitamins fermentation. So if you don't want to combine your DAP into your nutrient, then you're going to look at some other options. So the next question is, how challenging is your fermentation in terms of low YAN, high alcohol, etc.? If you have a fermentation that you anticipate being quite difficult or that you suspect is high in toxins, perhaps you want to start first with Spring Cell, which is the 100% yeast hull product, highly efficient as an aid for cleaning up stuck and sluggish fermentations so that your yeast can perform optimally. And that, of course, can be combined with a yeast nutrient. And if you're in that challenging fermentation, you're probably going to be looking towards Spring Firm Extreme, fully autolyzed yeast, rich in organic nitrogen, specially designed for difficult fermentation conditions. Or if you want to go the liquid nutrient route for ease of use, security, or efficiency, then you would be looking at Viniliquid, perhaps in combination with a Spring Cell and or with DAP. And then if you anticipate the fermentation is not going to be challenging, you're going to be in ideal or near ideal conditions, and you want a regular dry yeast nutrient, then of course Spring Firm is going to be your best choice. It's an all-purpose fermentation activator made of partially autolyzed yeast full of organic nitrogen, sterols, minerals, and vitamins that are crucial for your complete fermentation. And that, of course, can also be supplemented with DAP if you need to add a little bit more mineral nitrogen to it.
Great summary.
Excellent. Yeah. So let's get into the fun stuff. We've talked about how we prevent fermentation off flavors or how we fix our fermentation kinetics, but how do we drive flavors? How can the appropriate nutrient program drive positive aromas and prevent the off flavors in wine?
That's where the fun begins.
That's where the fun begins.
All right, so let's talk about every single aroma forming pathway in yeast metabolism. No, that might be a bit much, but we do want to we'll highlight some of what's going on in this very busy slide, starting with the glycolysis pathway, which obviously is central to the theme of wine fermentation. Necessity of your nutrients being in place in order to properly convert glucose and fructose to eventually ethanol, the byproduct that comes out the other side. Along the way, you also have some other side activities within the yeast, which can result in flavors that are hopefully positive. You'll see the green icons around the cell indicating approximately where they come from. So all of those are determined by all of the factors that you have in fermentation, most specifically if the yeast has the proper nutrients in order to go through its pathways properly. And up in the right-hand corner of the cell, you have the pop-out that highlights the vegetative aromas that may come from your grapes that you're probably going to want to express in your finished wine that you need proper fermentation for the yeast to behave. And then lastly, we'll mention just briefly that sulfur plays a huge component in the metabolism of yeast and is necessary for the formation of aromas, but also in a proper ratio in order to not form off aromas, specifically hydrogen sulfide. So
that was a great summary of this slide, of this complex pathways. All right, now that we've seen, all of that, maybe we can dive into specific part of this process in applied trials. So first thing is, let's talk about thiols. As you know, you have thiols precursors in, a lot of grapes, coming from, very aromatic whites like Sauvignon Blanc, Colombard, but also some rosé, Syrah rosé, Grenache rosé. You can have a lot of thiols precursors, and yeast is key in releasing these volatiles. And the choice of yeast is very key, but just as importantly is the conditions, temperature and nutrition. And in this trial, we're trying to highlight this. This is a fermentation of Sauvignon Blanc with our strain Safano SH12 that was specifically selected to promote thiols in white and rosé. And we tried in this trial to do a lot of different conditions in terms of fermentation temperature. You can see 12. 18 and to 12 at the end, and 18 Celsius. Sorry, it's in Celsius here. And then we also played with different nutrition program, whether we added DAP first or Spring Firm Extreme at 1/3, and try to see how it impacted the release of these key volatiles. The three thiols, key being the 3-MH, and you can see the type of aromas are associated with here, 3-MHA and 4-MMP. And something really stood out is that in the condition of temperature that are, good for the yeast to release, which is, not low, it should be medium to high temperature. Nutrition is going to be key. In the scenarios in red where we added DAP at inoculation, we minimized to completely eliminated the release of some key thiols, for example, the 4-MMP. No release of 4-MMP when we added ammonium at the beginning. So you chose your yeasts well, you put the right condition of temperature, and then you adapt. And I'm not going to go into the detail of the reason of the why. I'm happy to discuss this with anyone who wants to. But we see a huge impact. When you add Spring Firm Extreme or Autolysate at the beginning, you can promote the release of this aroma. So that's just a very key message, something, if you're producing this type of wine, something to really consider. Best compromise, add your organic nutrients first, ammonium later for really this specific type of aromatic profile, and just investing in the right yeast and using it properly. The second thing is, if we focus now on more fermentative aromas and specifically esters, this is a case study that we did on Chardonnay. And we have two different yeasts, one of them producing more acetate esters, the other one more ethyl esters, more complex fruit. And we analyzed, we did different condition of fermentation, and we measured the release of key esters here. First, you can see the yeast have different profile in esters. But you can also see we have the standard condition on the left, and then we played with temperature. We're not going to look at this right now, but we also played with adding nutrient, just under the form of just nitrogen, and not adding any nutrient compared to the standard, and adding just sources of lipids like hulls. And it's really interesting that for some yeasts that are mainly producing acetate esters, really adding a lot of additional nitrogen really helps promote esters. On the other side, some yeasts, that are more producing ethyl esters. And by the way, we provide this information to you, what type of esters our yeast are producing in all our technical data sheets. Don't specifically answer, positively once you started adding the minimum amount for fermentation. Adding more nitrogen is not always conducive to producing more volatile compounds. But adding lipids, we have seen, can be really, really beneficial in that case. So it also depends on the strain. Again, we go back to the nature of the yeast. Both lipids and nitrogen can promote esters, and more or less depending on the strain. And so, Sean, I'm going to let you kind of make a little synthesis of
try to wrap it in a little bow for us here. So what we've talked about, you just discussed ethyl esters, acetate esters, and touched on higher alcohols as well. We can summarize the three different groups of fermentative aromas as ethyl esters, like you said, having more of that complex fruit, some of that stone fruit, apple type characters, whereas our acetates esters are going to be more in that banana, melon, strawberry type flavors, and our higher alcohols are going to be very perfumey, floral, also carry a little bit of fruit character as well. So all of these are different layers of positive fermentative compounds. They can be negative at certain levels, so we have to be conscious of how we're promoting them and to what degree. But the general conclusions here are that with ethyl esters, its nutrition is an important impact for sure. And yeast derivative nutrients rich in lipids, especially added early on in fermentation, can promote them. And the products that we would use or recommend in this case would be Spring Cell, Vanilla Liquid, Spring Firm, Equilibre, and the ideal ratio of yan to sugar would be in that 0.8 ppm to sugar, to grams of sugar. And then with acetate esters and higher alcohols, we can see that there is a greater impact of nutrition, a greater benefit of yeast-derived nutrients rich in amino acids, especially added in the stationary phase. And in this case, we would recommend Spring Firm Extreme, and Vanilla Liquid. Greater effective addition in stationary phase, yes, we said. And then DAP can also have a very good impact for these as well. And the ideal ratio of yan to sugar is above 1. So, and if we want to talk about our yeast strains that can promote these different characters. Ethyl esters, we would recommend E85, S12, GBS 107. These are really good options. And then as far as acetate esters and higher alcohols, we would push you closer to BCS 103, CKS 102, HDA 54. And then there are others as well. So those are a few recommendations from us. But of course, like Anne said, all of this information is on each one of our TDS reports that you can find online and through ATP as well. And you can, of course, ask us anytime directly. So James, please feel free to take this over. As far as off flavors go, I think we definitely need to touch on the bad side of fermentative flavors. So please.
So in opposition to promoting the positive flavors that you're looking for in a wine, your nutrient program also plays a huge role in the management of off flavors. Specifically, we're talking again about H2S, hydrogen sulfide, can come from nitrogen limitation. Obviously, there's a large strain-to-strain variation with yeast, just as there is how yeast use nitrogen or the levels that you need for them. But what's most important for H2S formation is the level of cysteine and methionine relative to total nitrogen has a sweet spot. You don't want to be too high, you don't want to be too low, as that can promote the release of H2S. And then, of course, the vitamin calcium pantothenate is also needed for the synthesis of these aromas. So yeast derivatives such as spring ferm extreme provide the cysteine, methionine, and vitamins necessary to prevent H2S formation in your wine as you're trying to complete fermentation.
Yeah, and actually, when we have people coming with, lots that they have a lot of H2S issues and like, what do you suggest? This is the product that we recommend. They try as preventative, along with other measures. But, when it comes to nutrition, this is as good as it can get in terms of the right balance of nutrients.
Wow, we made it.
It was a lot.
There was a lot. There's a lot in here and a lot to digest for sure. I guess the main takeaway is that all of this information is available to you at any time. Of course, and we are available as well to dig even deeper. To conclude, let's kind of talk about everything that we have learned. Adequate nutrition must serve two main purposes. And that's fermentation performance and our fermentative compounds, right? Both positive and negative. Yeast has complex nutrient requirements. We learned that. We learned that each one of our nutrients has a whole different layer of components to them: minerals, vitamins, lipids, nitrogen sources, and then the use of yeast derivatives helps to meet those needs. And each one of our products is formulated for different reasons, depending on the need of your fermentation. That's kind of the sum. You guys have more to add?
I would say yes. Just to summarize, when you make adjustments, they really need to be, first of all, made according to your initial must and needs, at the right quantity. Hopefully, we helped you figure that out at the right time. Hopefully, we helped you figure that out with the right product, with the right balance of mineral sources of nitrogen and yeast-derived product. Hopefully, we helped you understand their nature, but also very, very importantly, based on your objectives, whether they are based on performance, analytical, aromatic, and we are really here to help you, build the protocol to make the wine of your dream, the wines of your dream. So I just we added that last slide just to to remind you of our email addresses. So if you have any question Feel free to email us as a group, individually. We'll make it arrive to the right person in any case. That was just my last word, and thank you so much for staying tuned until the end of this very, very rich in information webinar, and appreciate you.
Yeah. Thank you to everybody. Thank you, James, and thank you, Anne, for being a part of this, and wish you all very well.